Hi, everyone. I'm Joe Weinman. It's a pleasure to meet you all for the first time. I'm going to be very brief. I'll just say that I'm delighted to introduce a longtime personal friend. We do keynotes in China all the time together. I've got a million Piero Scaruffi and Joe Weinman stories that, thankfully, I don't have time to share with you. But Piero Scaruffi is an amazing polymath. He just has a background in art and physics and philosophy, and of the last 5 or 10 years, AI. His knowledge is encyclopedic, and he's going to go through, I don't know, 50 or so of his 12 trillion slides that he puts together and maintains and stays abreast of trends. I don't want to waste any of your time by continuing to introduce him because he speaks for himself. So please join me in welcoming Piero Scaruffi to the stage.
Hey. Okay, thank you, Joe, for the fictional bio. So I've been in Silicon Valley for a long time. In fact, I've written what I think is the thickest book ever written on the history of Silicon Valley. And I've been in AI since the 80s. That's down there. It's a picture of me in the golden days of AI in the 80s. And then I've been through the winters and so on. And one book I've written recently is titled Intelligence is Not Artificial, which tells you that I'm not the one who will sell you hype tonight. And AI obviously is very famous. I saw this article on Forbes magazine that said it's the new Burning Man. It's so popular that it rivals with Burning Man. These are some of the most important conferences in AI, and I couldn't get into this one, sure enough, and it was sold out the first day. So very popular. Most of the people who go to these conferences, by the way, today, get disappointed. It's not the AI they expect. That's one big problem I also saw at this conference. A lot of the questions were assuming that AI is everything that is automation, everything that is computation. By the way, this conference was very useful for me to realize how ignorant I am in your industry. So some of the sessions, and I had no idea there's such complexity out there. I'm going to give you a sort of state-of-the-art of what I consider the real AI. And if you have questions, you're welcome to talk to me after my talk and ask specific questions. So first warning, artificial intelligence is a very large field, and it's been around for a long time. And what today most people focus on is deep learning, which is just a piece of the pie. Deep learning was born in 2006, 2007, depending on who you credit. These are the three gentlemen that usually are credited for inventing deep learning. Nothing is invented, everything is evolution, right? And it became very popular in 2012. There's a yearly competition in which neural networks compete to recognize objects. So the error rate used to be about 30% to 25%. 2012, this neural network, which is now known as AlexNet, went down to 16% error rate, and now we're below 3% or 2%. And those were students of Jeffrey Hinton, the first gentleman up there. So everybody started talking about deep learning after 2012. The question you should ask me is, why did it take until 2012? And that question actually is not trivial. It tells you, if you're not familiar with the field, it tells you some important things. So number one, the computational power. When I was doing AI in the 80s, I was dealing with machines that were pathetically slow. And with neural networks, especially deep learning, which means very complicated neural networks with many layers, requires huge computational power. Now, I always say luck. By sheer accident, the computational power of GPUs invented for video games skyrocketed almost exactly when deep learning was invented, when we needed it. So there was a major gift. Second, data sets. You probably heard this over and over again. In fact, now we are emphasizing it a little too much. Anything that has big data is automatically called AI, which is not true. In the old days, it was automatically called statistics. And in most cases, it's still statistics. So the data sets that deep learning needs are big, really big. Sometimes you need millions of data, and have to be the right kind of data set. And so those also became available between 10 and 5 years ago, and we are still developing a lot of data sets to train neural networks. And then software. Software is complicated. I always tell people AI is mostly free. You find a lot of open source software. It's not easy, but it's mostly free. These are some of the most sophisticated development environment. And again, they were all realized, implemented about at this time. So I told you deep learning is what most people talk about. People in AI love to come up with very complicated names. And I'm going to talk about some of the technologies within deep learning with these very awful names. The first two are fairly well known at this point. Those are the kind of deep learning that gave us face recognition, speech recognition. The second one gave us machine translation, when in 2016 Google switched to an RNN. The quality of the translation improved dramatically. So you've seen this in practice, even if nobody puts the sticker. This is a convolutional neural network. DRL, deep reinforcement learning, is also popular. AlphaGo, if you heard of AlphaGo, that's the quintessential example of deep reinforcement learning. It's been obviously very successful in game playing, and now it's used a lot also in robot training. And then GANS, I'll spend a few more words on GANS because it's kind of newer, and it has some different approach to artificial intelligence. So I will skip CNNs and RNNs precisely because we already have speech recognition, face recognition, and we talk a lot about those things. Deep reinforcement learning, as I said, became popular with AlphaGo, which then evolved in AlphaZero, AlphaStar. So these are systems that play games better than world champions, and Go was considered the kind of the ultimate complicated board game. So when it was solved, there was a major event. People thought still AlphaGo, playing Go is still very far from playing strategic video games that any kid can play. And so recently in the last year, both Google DeepMind and OpenAI, which is Elon Musk's startup, if you're not familiar with it, they both developed systems that can actually play strategic video games. And that's a major advancement for a number of reasons. And OpenAI just a few months ago, I think a few weeks ago actually, showed this system that can solve Rubik's Cube. The software solution has been around for a while, but this is a robot that physically uses its fingers to solve Rubik's Cube. So also some practical applications of this technology. Now, the other thing that is relatively recent and is generated quite a bit of interest is this one. Now, to explain why it's different and why people are excited about this, I go back to the idea of a concept. If I ask you to sketch a dog, you will do something. This is my artistic rendition of what a dog is. Now, it's not a real dog, right? But how did I do that? Well, I did it because I have the concept of what a dog is. So neural networks were very good at recognizing dogs. But if you ask a neural network, show me what a dog looks like, it wouldn't know what to do. Well, this one does. That's the historical paper that made them popular. And in the paper, it says, these are pictures of objects that don't exist. Okay? You ask the network, show me a chair. and the network generates the image of a chair. So it's a different approach, and for both philosophical and technical reasons, it's a major step in the development of artificial intelligence. And today's system, today's GANs, can do this very high resolution. So you can have, you can ask pictures of a fruit, and it will show pictures that look like photographs of real fruit. So that has been used in different ways, and just to give you an idea of the power of this technology, you can write a sentence, and then the network will generate a picture that represents that sentence. And if you put many sentences one after the other, what do you get? A script, the script of a video. And so that has been done. It actually was done the first time 3 or 4 years ago, but of course when Google does it, everybody pays attention. So Google DeepMind created short videos just based on the script. So that could be the future of Hollywood, where you write the script and then give it to the network, and the network generates the video with very realistic looking actors. And the same technology is being used to do style transfer. What's style transfer? This is probably the most famous, developed at UC Berkeley now it's 3 years ago. One picture is the real picture, the zebras. And the other picture, you just ask the network, show me the same picture, but replace the zebras with horses. And that one is a summer picture. And then you ask the network, show me this panorama in winter. NVIDIA created a very simple app that uses this technology of style transfer. I believe this should be online. You sketch something, and then the network creates a photorealistic picture of that something. So in this case, just a few lines and some colors tell the network, okay, I'll generate the picture of a waterfall in a canyon. Then I want to mention a little bit of progress about the progress in natural language processing. Traditionally, this is one of the hardest areas of AI, just understanding what I'm saying now. I assume everybody does here, despite my Italian accent. And it seems trivial to humans. It's not trivial to machines, right? So in the last 3 years, there's been major progress thanks to these systems and many other systems, but these are some of the most influential today, coming from very different labs. And initially it sounded weird that deep learning would help in natural language understanding, but right now it is giving some results. I will skip all the details, but give you an idea of what you can get. Realistic. I mean, people talk about computers writing poems and so on. This has been done since the 80s, and it's not really very useful. But this is useful. This is, you give the computer a text to read, and then you ask questions about the text. That's the simplest application of natural language processing. It's something that humans can do normally. You read a book, and then I ask you a question about the book. And if you remember something, you will give me an answer. So this is an example where GPT-2 can answer questions such as, who wrote the book, The Original Species? Not because the answer is in a database, but because the answer was explicitly or implicitly in the book that he read. And that's something we normally do. And then with some probability, and these are the correct answers, and it gets, with very good probability, the answers. So that's also major progress happening today that may have an impact on how we process information. So there are at least 3-4 areas where progress in AI is real. It's not hype, okay? Now we can talk forever about the practical applications. I also want to spend a few minutes discussing the limits. First of all, that's the neuron in the machine, that's the neuron in your brain. the difference is colossal. And neuroscientists can spend hours telling you how much more complex our neurons are. Second, we also underestimate that machines do something intelligent when we structure the environment for them. When you look at the picture of the Google car, you tend to look at the car. You should look at the white lines. You should look at the traffic signs. Those are very important for the machine to do something that is quote unquote intelligent. We made it easier for the machine to self-drive. It is self-driving, but actually we made it possible for the machine to self-drive. And don't underestimate our brain. Machines are still very far from doing what we do. I calculated from the Google paper, I calculated how many watts AlphaGo uses. I came up with 440,000 watts. Neuroscientists tell me that our brain uses 20 watts. Now, AlphaGo can do something I cannot do. I cannot play Go at all, actually. But I can do an infinite number of things, including talking to you now, going shopping, looking for my wife after this talk, and so on. Very difficult tasks. I can do many of them, infinite. I can learn another one right now. So still a big difference between machines and humans. And so I'm not surprised that the self-driving car is failing in many ways right now when it is in the real environment. In Silicon Valley, we joke, we call it the self-crashing car. And the fundamental problem is common sense. Humans have common sense. Machines, unfortunately, don't. This was a famous post by Google in 2014 where it showed the machine recognizing scenes. Like that, there are 3 dogs in the machine that says 2 dogs play in the grass. That's impressive. It's 3, not 2, but that's impressive. Most famous was the Frisbee. The Frisbee is barely visible, and still the machine wrote a group of young people playing Frisbee in the field. That's very impressive. What almost nobody shows you is that one. That one, the machine wrote a refrigerator full of food and drinks. That's not a mistake. That's a stupid mistake. I can make many more mistakes, but hopefully I will never confuse a traffic sign for a refrigerator full of food. So what is the fundamental problem? That deep learning is unnatural. You have to show 1 million images of a banana before the machine can recognize the banana better than a human. You show a banana once to a child, it will know what a banana looks like. You can show the banana once to a monkey, it will know what a banana looks like, okay? So the difference is still colossal. Playing, AlphaGo had to play millions of times against itself. You show me Go in 10 minutes, I will start playing. Badly, but I will start. So there's still something very unnatural in deep learning. And don't trust me. This is Yann LeCun, one of the inventors of deep learning, and he's talking about self-supervised learning that does something a little more natural. Don't have time to get into detail. But the bottom line, there's a lot of work to be done before we build the machines that you see in Hollywood movies, okay? That's different kind of AI. What can AI do? Years ago, I was telling people, my dream is machines that can recognize skin cancer or can recognize the possibility of a heart attack before it happens. Well, this is reality. This is now, these are systems that exist in many parts of the world. And I think we are getting closer to helping scientists solve problems they've never solved. That's an animal that doesn't die unless you eat it, kill it. That's an animal that gets younger every now and then. And that's the oldest woman who ever lived. What is special about their genes? Well, the answer is so complicated, nobody came up with anything that is really useful. I think AI can help. These things could become useful, feasible in the near future. And the problem for scientists is that this is terribly complicated. More than 1 million people, I skipped one slide. Millions of papers are published every year in life sciences alone. Who can read all of them? Then AI is already useful for the aging society. This is a problem that we share with China, Japan, Europe. In telecom, this was a warning slide. In telecom, a lot of hype. This is in every industry, okay? I read this sensational news. The reality is there are pretty much 5 areas of application of AI in pretty much every industry. I keep seeing this over and over again. Optimization, preventive maintenance, and you know, these are some of the systems I found by Googling. I'm not particularly creative here. Virtual assistance, fraud detection, there's one more. Anomaly detection. These are classic cases where deep learning can help. There's lots of data available, and deep learning is mature enough to do this. Thank you very much.